Okay, this short video tutorial is going to show how to get this positive x-intercept right here. So I'm using the equation that's provided at the top of the reflection sheet. I will also go to y equals so that you can see my equation here. If you'd like to pause the video, you can pause it now and type that into your calculator. I do recommend doing this actual process with me instead of just watching. This is the window that I'll be using. And the only thing I changed in the window was my Y max so that I could see the top of the graph. So if you need to change your window, you can pause the video and type in these numbers. And I'm going to go to my graph. So here's my graph. I'm trying to find this x-intercept because this represents when the object hit the ground, how long it took the object to hit the ground, how long was the object in the air. That's what this number is going to represent. So in order to do that, I'm going to go to second and trace. So as I did for if I'm finding the y-intercept or the vertex. And this time I'm going to go to this function that says 0. Or you can just press the number 2. And just like last time, it's going to ask me for left bound and right bound. Now, I'm going to recommend for these projectile type problems, the same thing I would recommend for the vertex. Because I'm looking for my positive x-intercept, I know that my 0 is to the left of it, so I'm going to type in 0, enter. And I know that my graph ends over here at 10, and that is definitely to the right of my x-intercept. So I'm going to type in 10, enter, for my right bound. So you can see the calculator has these little arrows. This one's cut off a little bit over here, and it's going to give me my x-intercept between these 2 points. So it says guess, and I'm going to confirm that I want it to guess. And here's my x-intercept. So this kind of freaks people out sometimes when they see this because they think, but wait a minute, the y value was supposed to be 0. So don't let this distract you. This is the calculator's way of telling you a very, 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 very small number in scientific notation. If we were to round this to the hundredths, it's 0. So don't get distracted by this when you see it. It really is, for our purposes, the equivalent to 0. What we're focused on is this x value right here. So if I were to round this to the hundredths, it would just be 6.09. And this could, at least in this problem, represent how long the object was in the air.